Good morning, everyone, on this gloomy day. Thought I'd show you I'm still here. I have a new phone holder. We are ready to go. So I'm going to just go over the homework so that you can see if you got it right and if you understand. So the very first one, number 1, we start with the nth term test all the time. Excuse me, Miss Den. You said test. Dylan, sit down. We don't have a test. We're just talking about the nth term test for series. Okay, you said test, so I thought maybe we had a test. No, Dylan, you're fine. Okay, thanks. So we start with the nth term test. We see that the bottom is growing faster than the top, so we know maybe we're going to converge. The second test we try is geometric. This is not geometric. If I get the first few terms, I'll see also that it's not. So then I go to either direct comparison or integral. I'm going to always go to integral next. And if I have an n on the bottom, I can disregard this. I could bring the 5 out, looking at this as 5 times 1 over n. Well, I know that diverges because the power of n is 1 or less. So therefore, this is going to diverge by the integral test. You want to be able to say which kind of test you're using so that you don't really have to give much of an explanation other than the test that you're using. Number 2, nth term test. Yep, it's worth continuing. This is not geometric. So think about this as the integral again. Take the 3 out. I've got 1 over n to the 1/2. That is a power again of 1 or less. So this series is going to diverge by the integral test. Okay, cool. Number 3. If I look at the nth term test, the bottom does grow faster than the top. The logs don't grow fast. They're like the slowest growing thing. So I know that I should keep going. This is not geometric. The integral is not so easy because I don't know how to compare them or what the integral of that is going to be. So I'm going to have to resort to that direct comparison test. Well, guess what? I know that the series 1 over n diverges, right? That's our p-test. We know that that diverges. Well, the natural log of n over n is bigger than 1 over n. So therefore, our series diverges too. You know, I think I might have forgotten to assign the Khan Academy. Shoot, I hope I didn't. Oh well, I'll go fix that now after this if I did. Number 4. So nth term test, yep, keep going. This is just integral test again. This one is not important. So I can look at this as 1/2 of the integral of 1 over n. Well, that's going to diverge. The power of this is 1, so this is going to diverge by the integral test. Number 5. Hey, a geometric test. So number 5, the bottom is growing faster than the top, so it's worth continuing. How did I know it was geometric so fast? The power of n. So I had this power, there we go. I had this power of n, so that's gonna like tip me off that this is geometric. So if I write out the first few terms, n equals 1, so I'm gonna have 1 over that natural log of 2. Then when n is 2, 1 over the natural log of 2 squared, 1 over the natural log of 2 to the 3rd, and so on. So I don't care about my first term. I would only care if they asked me what the actual sum was going to be. The actual sum would be a over 1 minus r. But they only want to know if we converge or not. So I need to know what's r. R is my multiplier. I have 1 over the natural log of 2. And I need that multiplier to be less than 1. Is it? Yup. So this converges by geometric test. All right, number 9, I put a star because it's a little wacky. Okay, so the bottom is growing faster than the top, so I can, the nth term test tells me to keep going, so fine. So, yeah, this one's a little bit crazy. Okay, so let's consider the direct comparison test. I'm not going to be able to use integral for this. Actually, you know what? Never mind. I should use integral for this. Let's be smart. Get rid of that. So this is basically the same thing as root n over n squared. So this is like the integral of root n over, root x over x squared. But if I reduce that further, this is x to the 1/2 over x squared, which is really 1 over x to the 1.5 or 3/2. There we go. And look at the power on the bottom. The power on the bottom is bigger than 1. So yay, this converges. So therefore this does too. So my series converges by the integral test. Miss Dunn? Yeah, Dylan. That one kind of was confusing. Yep. Okay. Number 1 again. Isn't that fun how that happened? Just kidding. The numbering is just weird. So number 1, oh no. Direct comparison test. I'm sorry, nth term test when I look at it. Finally, the nth term test is helpful. Look at the limit. As n goes to infinity of n over n plus 1. I have equal degrees on the top and bottom. That means the limit of this just goes to 1. That is not 0, sillies. I agree. So since the limit as n goes to infinity is not 0, this is going to diverge right away by the nth term test. Yay. All right, flip it over. Only one more on here, number 11. Number 11 hopefully looks to you as looks geometric to you, which it is. So nth term tells me keep going. My bottom is bigger than my top. 3 to the n is going to be bigger than negative 2 to the n. So I have powers of n, so this is geometric. So let's get some terms. Plug in 0. I have 1. Plug in 1. I have negative 2/3. Plug in 2. I have 4/9. Plug in 3. I have minus 8/27, and so on. So my multiplier here is negative 2/3. Double check from here to here, from here to here, we got it, negative 2/3. So the absolute value of this is less than 1. We are good to go. So this is going to converge by geometric test. Yay! There's the homework. Hope you're getting it, and we'll meet on the chat. Have a great day.